ผมไม่ได้นี่6 that all right this one and this one as well ไปแล้วนะครับอีกอันหนึ่งอันนี้จะเป็น1080 60ได้ครับน่าจะชัดนะครับต้องส่งลิงก์ให้คุณเนาะโอเคไลฟ์นะครับส่งลิงก์ให้คุณหมดครับโอเค let's talk about our midterm exam, right? It's worth 8 marks, right? I have shown you 8 คะแนนครับจากสอบทั้งหมด20 คะแนนตามภาคครับก็8 คะแนนบทที่1บทที่2 12 คะแนนบทที่2เดี๋ยวไปออกข้อสอบครับเพราะว่าดูก่อนว่าถึงเราจบถึงไหนได้นะครับ The first problem is something about C lambda f, right? C equal lambda f. And the second problem is related to amplitude modulation in that's the way also related to C lambda f as well. In the third problem is the story about 2 polarization filters. Okay, you need to compute the light intensity. Okay, it's not current. Okay, but it uses also the variable its light intensity. Okay, and okay, you have 2 filters and the angle between 2 filters exactly as you have seen in the lecture notes. Okay, nothing different from that. Okay, because I want to not let you get failure. Okay, get fail from the exam. Otherwise, it will have again the problem because anyway I have to bring you to at least 50% of the midterm exam score, right? It caused a lot of problem as in the previous year. Okay, and in the third problem, okay, the second problem is worth of 1 mark. Okay, 1 point. In the third problem is something about okay, polarization filter. It takes 2 points. Okay, 2 marks. In the last problem, it's something about reflection of the light that propagates through 2 media. Okay, you have 2 homogeneous media, 2 types of media, and the light just pass through the border of those 2 media, and then you get the reflecting component, and you have to be able to calculate the angle, okay, with respect to the normal of the border plane, right? That's what I have shown you on the whiteboard already, and you have also done the homework related to that. ผมข้อสอบไม่ยากนะครับใช่ไหมเน้นให้คุณรู้เรื่องของพื้นฐานนี่แหละครับ and what else เสียงไปได้ชัดเจนนะ in the last problem it's worth 4 points. Okay, 4 marks. In this is because we have 2 different cases. The first case is during the daytime, right? The light gets into the water and it passes the border between the air and the water. Okay, you have to be able to calculate the reflecting angle, the reflecting angle, okay, when the light is completely polarized or linearly polarized, right? That's the situation during daytime. And in the second scenario, at night time, okay, the owner of the swimming pool has the floodlights, right, on the floor of the swimming pool, and they just turn on the lights, and the lights start to propagate inside the water in the swimming pool, and it reaches the border between the water and the air, right? And you have to be able to calculate the reversing propagation in this way, right? You have to find the angle of reflecting component, the angle of the reflecting component, okay, and that's it, okay. 2 parts during daytime and 2 parts during nighttime. So in the last problem, it's worth 4 points. Okay, you can see that 1, 1, 2, 4, right? So in the whole examination of the first chapter, it contains 8 points. Okay, everything is clear. All right นะครับผมชี้แจงคุณอย่างละเอียดแล้วนะครับว่าข้อสอบเป็นอย่างไรนะครับก็มีรู้สึกปัญญา604ที่อะไรนะมีปัญหาไม่ยอมเปิดกล้องนะครับก็ยังเซตหน้าจอมานะครับคราวหน้าผมไม่บอดคาสต์วิดีโอไปหาคุณนะครับคุณบอดคาสต์วิดีโอมาหาผมเพื่อว่าผมจะได้ดูนะครับว่าคุณให้ใครมาช่วยหรือเปล่านะครับเวลาทำนะครับเพราะว่าคุณนี่ถือว่าอลุ่มอล่วยมากแล้วนะเพราะว่าไม่เหมือนรุ่นพี่ไม่ได้เหมือนสอบห้องนะครับอันนั้นมีคณะกรรมการคุมสอบนะครับอันนี้คุณนั่งอยู่ที่บ้านคุณใช้อิเล็กทรอนิกส์แคลคูลเลเตอร์เครื่องคิดเลขแบบที่ผมโชว์ให้ดูนะครับเครื่องสี่เหลี่ยมในกล่องนั้นหรือคุณจะใช้เครื่องคิดเลขที่มีอยู่ในเขาเรียกว่าอะไรใน Google ในอินเทอร์เน็ตอะไรก็ได้แล้วผมไม่มาแล้วโอเคไหมขอให้คุณคิดเลขหรือถ้าคุณไม่ใช้เครื่องคิดเลขคุณมองเลขแล้วสมองคุณมองออกมาเป็นผลลัพธ์ก็ไม่มีปัญหาขอแค่ให้มันถูกโอเคไหมครับเน้นที่คำตอบถูกแม่นยำแล้วก็หน่วยถูกต้องนะครับเพราะการที่คุณระบุหน่วยถูกต้องก็คือคุณรู้ว่าปริมาณนั้นคืออะไรในวิชาฟิสิกส์ของเรานะครับผมชี้แจงคุณคิดว่าไม่น่ามีอะไรขาดตกบกพร่องแล้วนะเรื่องข้อสอบนะครับใช่ไหมครับก็ถ้ามีอะไรที่คุณยังไม่เคลียร์ข้างแข็งใจนะครับก็เรียนเชิญถามผมได้นะตอนนี้แต่ว่าตอนสอบอยู่ห้ามถามนะครับเพราะว่าเดี๋ยวมันเป็นผลได้ผลเสียไม่เท่ากัน604 605 604ผมก็บอกเช่นเดียวกันแล้วเดี๋ยวข้อสอบเป็นอย่างไรนะครับคุณเตรียมกระดาษไปเลยสำหรับคนที่ไม่ใช้ Good Notes นะครับโอเคไหมคุณถ่ายรูปแต่ว่าต้องรวมไฟล์ครับใครที่ถ่ายรูปมาทีละแผ่นส่งตัดคะแนนนะครับคุณต้องรวมไฟล์เป็นไฟล์เดียวกันไม่ใช่มาถ่ายทีละหน้าปุ๊บแล้วคุณไม่เขียนเลขหน้าด้วยโอ้โหแล้วผมก็งงดิครับคนตัวก็งงมันไม่ได้มีคนเดียวนะครับคุณเห็นใจผมด้วยเพราะผมเองก็มีความเครียดนะครับเพราะว่าต้องส่งคะแนนคุณภายในวันนี้แล้วถ้าคุณตกผมก็ต้องมอบหมายงานให้คุณทำอีกโอเคไหมมันก็ไม่ง่ายเหมือนกันคนสอนก็เครียดเหมือนกันโอเคไหมครับพยายามอย่าตกนะครับข้อสอบชี้แจงคุณง่ายๆชัดเจนอยู่แล้วโอเคไหมไม่มีดิ้นไปกว่านี้ถ้าผิดไปจากนี้คุณตัดคะแนนผมได้เลยเพราะฉะนั้นบอกเขาเลยว่าไม่ควรให้คนนี้สอนอีกโอเคไหมwhat else okay that's what I have told you about the midterm exam please don't cheat during the midterm exam okay don't use the line or any remote communication method to talk with your colleagues okay during the exam don't ask your colleagues in M604, okay, who would have finished the exam before you start, okay ห้ามถามห้อง604นะครับเพื่อความยุติธรรมคำตอบเป็นเลขทศนิยมโอเคไหมครับอย่าติดเป็นเศษส่วนต้องใส่หน่วยนะครับผมชี้แจงไปแล้วว่าถ้าไม่ใส่หน่วยผมจะตัดคะแนนอะไรยังไงนะครับแจ้งไปแล้วคือข้อสอบมันไม่ยากนะโอเคไหมสอนยังไงก็ออกแบบนั้นตรงๆนะครับโอเคไหมand then so we will start our section in I have to share right I have to talk with you about the class attendance for today, right? Yeah, class attendance. ผมแชร์หน้าจอให้คุณนะครับใช่ไหมครับเดี๋ยวผมขอเช็คที่เอาไปไหมครับเหมือนว่าไม่ไปนะไปไม่เอ่ยคนอยู่ที่ซูมเห็นหน้าจอผม05นะ this one right okay ไปไหมครับซูมเห็นหน้าจอผมไหมเอ่ยผมแชร์แล้วนะกดแชร์แล้วstart ต้องรอเนาะโทษนะโอเคไปแล้วนะครับนี่นะก็มาว่ากัน M605 right for the people in YouTube I'm not sure I'm going to open the class attendance file for M605 ยังมีรุ่นพี่คุณครับคุณที่เขาตกไปฟิสิกส์อันหนึ่งด้วยวิชาแรกเทอม1เนี่ยใช่ไหมเพิ่งส่งการบ้านรวมอันนั้นปีนั้นเขาทำเยอะ24ชิ้นนะครับ20กว่าชิ้นนะครับทั้งเทอมนะครับผมให้แก้0ก็คือคุณไม่ต้องสอบละคุณทำการบ้านมาชัดๆห้ามผิดโอเคไหมครับผมไม่มานะคุณจะถามเพื่อนคุณถามแล้วคุณไปฝึกทำมาให้คุณมีสกิลทั้งเทอมของเนื้อหาทั้งเทอมนะครับนั่นคือคนที่ตกครับพยายามอย่าให้ตกนะโอเคไหมครับคนสอนเองก็ไม่อยากตรวจการบ้านคุณใหม่นะผมก็ปวดหัวเหมือนกันนะครับผมก็ไม่ได้ชอบนะวิชาฟิสิกส์ครับเขามอบหมายมาให้ผมสอนครับโอเค for the people in YouTube I think that you can see right on the monitor we are talking about the class attendance file right this one so let's start in both first Zoom right because you cannot right now at the moment I have no ability to let you send me the video through the YouTube channel okay only the Zoom way โอเคขออนุญาตให้คุณเปิดชื่อno เปิดกล้องนะครับให้ผมเห็นหน้านะครับตามเขาเรียกว่าอะไรตามเดิมของเรานะครับโอเคดีมากครับโอเคก็เข้าใจนะครับมีคุณครูบางท่านอาจารย์บางท่านแจ้งบอกว่าไม่อยากให้คุณเปิดนานเพราะว่าพอคุณเปิดคุณส่งสัญญาณมาสัญญาณมันก็จะอะไรนะเรียกว่ามันก็จะกินแบนด์วิดต์ของเน็ตคุณด้วยใช่ไหมเดี๋ยวคุณก็จะได้รับภาพกระตุกจากฝั่งผมใช่ไหมครับก็แป๊บเดียวเปิดแป๊บเดียวแล้วเราก็เลิกคุณไม่ต้องส่งแล้วจากนั้นคุณจะไปอยู่ YouTube คุณจะไม่ดูอีกแล้วคุณจะอยู่ซูมแล้วติดขัดตรงไหนแจ้งผมทันทีนะครับไม่ว่าช่องทางไหนนะครับผมทำให้คุณมากที่สุดเพื่อไม่ให้เกิดการสูญเสียโอเคไหมไม่อยากให้okay let's talk about our story right the first person ก่อนครับก่อนอยู่ตรงโอ้สีน้ำเงินนู้นเนาะก่อนโอเคชื่อตัวหนังสือมันบังหน้าบังตาคุณครับเห็นข้างบนหัวคุณแต่คิดว่าน่าจะใช่คนเดิมเนาะอ๋อคุ้นโอเคนะคล้ายๆเดิมโอเค the second person ปานธรครับปานธรอยู่ต่างประเทศนะครับวิวต่างประเทศสวยงามหน้ามืดๆหน่อยนะครับผมมองไม่ค่อยเห็นหน้าคุณนะคุณจะเอาฉากหลังก็ได้แล้วแต่คุณ the third person วชิรวิทย์ครับวชิรวิทย์อยู่ไม่เอ่ยวชิรวิทย์ครับวชิรวิทย์เรียบร้อยหน้าเดิมเห็นหน้าชัดๆอย่างเงี้ยจบเลยโอเคไหมครับfourth สุภวิทย์ครับสุภวิทย์อ๋ออยู่ deep space เรียบร้อยสีน้ำเงิน blue นู่นนะครับนัทวิน number 5 please นัทวินเรียบร้อยเห็นหน้าชัดเจนครับsix กฤตภพครับกฤตภพโอ้มืดหน่อยโอเคได้ไม่เป็นไรครับกฤตภพแล้วต่อไปseven right ภวิทย์ภวิทย์หรือภวิทย์โอเคเรียบร้อยครับอยู่ตรงน้ำนี่นะครับโอเค number 8พีรทัศน์ครับพีรทัศน์เรียบร้อยครับโอเคชัดเจนครับสวัสดีครับกฎชวงวัดครับnumber 9หมายเลข9ครับกฎชวงวัดปาฏิหาริย์มาแล้วกฎชวงวัดเรียบร้อยเห็นหน้าเรียบร้อยครับมุมกว้างnumber 10ภวัตครับภวัตเรียบร้อยครับ United States of America โอเคnumber 11 which ครับ which อยู่ไหมครับ which เรียบร้อยใส่แว่นนะครับคุณกดอ๋อมันกล้องจากแล็ปท็อปใช่ไหมมันจะเงยนิดนึงนะโอเคไหมไม่เป็นไรครับwhich ไปแล้วธนากรสีขาวเรียบร้อยเสื้อสีขาวเหมือนเดิมมุมเดิมเรียบร้อยครับ13 right ปาฏิหาริย์เรียบร้อยครับโอเคครับสวัสดีครับฉากหลังในหนังด้วยนะครับ14ธนาธรทองสุขครับธนาธรทองสุขเห็นเรียบร้อยครับหน้ามันจะโอเคกล้องมุมกว้างเนาะธนาธร15กิติวัฒน์ครับกิติวัฒน์สะพานซานฟรานซิสโกเช่นเดิมโอเค16ธีรุธครับธีรุธหอมชื่น605น่าจะไปได้เร็วเพราะว่าไม่เสียเวลาติดขัดในเรื่อง604เละโอเคไหมครับด้วยปัญหาเทคโนโลยีคือผมเพิ่งย้ายมาที่ iPad ยังรอธีรุธอยู่นะครับธีรุธนี่น่าจะเป็นคนที่ชอบหายไปหรือเปล่าธีรุธ where are you please let me see otherwise I'm going to leave the state of absence okay to you ธีรุธ 1 2 3 if not then absent นะครับขอลงเป็น absent นะห้ามโกรธกันนะเห็นไหมครับรันแล้วใน YouTube นะครับเห็นไหมใน iPad มันรันลาเทคไม่ได้ผมยังใหม่อยู่นะครับ let's skip to the number 17พฤตินันครับพฤตินันภาพขึ้นไหมครับพฤตินันหน้าจอดำนะครับพฤตินันว่าไงพฤตินันเรียบร้อยมุมนั่นนนทกรพฤตินันใช่คนสีเหลืองเนี่ยใช่ภาพเดิมโอเคเรียบร้อยครับพฤตินัน and then number 18ปัณณทัศน์ครับปัณณทัศน์หรือปุณณทัศน์ปัณณทัศน์เรียบร้อยมุมเดิมนะครับโอเค19นนทกรม่านสีแดงส้มสวัสดีครับเหมือนเดิมเช่นเดิมเรียบร้อยครับง่ายๆเลยเปิดมารอแล้วนนทกรนะครับเรียบร้อยมาก20วารินทร์ครับเปิดรอโอเคครับนอนสบายครับเปิดรอผมนะครับเพื่อไม่ให้เราเสียเวลาเนาะเลขที่ถัดไปอะไรเปิดมารอเลยนะครับแล้ววิพลนะครับผมจำได้ว่าแล้ววิพลเป็นยังไง โอเควันนี้เปลี่ยนฉากมาเป็นวินโดว์ครับโอเคจำได้ครับโอเคแล้ววิพล22วารินครับแล้ววิพลเหมือนว่าลืมส่งกันบ้านนะคุณตามส่งย้อนหลังด้วยนะครับแต่ต่อไปผมจะไม่ให้เต็มนะคนตามส่งไม่มีสิทธิ์ได้1เท่าเพื่อนนะเต็มที่ให้ได้มากสุด3.4 25% okay that's the best case because you are not on time ถ้าไม่ส่งก็เป็น0นะครับโอเค22 วารินครับวารินare you there วารินนี่คนในท้ายนี่มีเวลาเหลือเฟือโอเคครับ if not then I'm going to mark you as the absent status okay and you may let me know later if แต่จริงๆไม่ควรออกไปข้างนอกนะเพราะว่าช่วงนี้มันอันตรายนะครับโอเคไหมเป็นหมื่นละทุกวันนี้คุณอยู่กับบ้านเถอะนะครับยกเว้นมีธุระจริงๆอ่ะโอเคไหมค่อยออกไปนะครับผมยังไม่ได้ไปตัดผมเลยนะครับทุกวันนี้23 พระสิทธิ์ครับพระสิทธิ์รอเห็นมุมเดิมนะครับที่อนุสาวรีย์ประชาธิปไตยอันนี้อยู่นะครับโอเคไหมครับสวัสดีครับโอเคบาย thank you then let's move to our story which is the most important and good all right okay I hope that you can see everything I'm not sure whether สำหรับคนที่อยู่บนYouTube นะครับถ้าผมแบบนี้คุณจะเห็นไม่ชัดใช่ไหมครับใช่ไหม YouTube ที่เป็น1080ไม่มีใครดูเลย1080ดังนั้นไม่เป็นไรเพื่อความชัดเจนนะผมเปิดไฟล์ที่มันชัดๆร่วมด้วยแล้วกันครับwe're gonna use this version right I think we arrive at the second problem in Biosawat law, right? Which is on page 74, right? 74นะไปได้5หน้าครับห้อง604นะครับผมเสียเวลาไปกับอิเล็กทรอนิกส์ซื้ออิเล็กทรอนิกส์เนี่ยนะครับผมครั้งแรกเองนะครับบน iPad แล้ว iPad มีปัญหาหน้าจอค้างครับกดไม่ไปเลยโอเค so now we are talking about the Biosawat law right which should be one part of our midterm exam let's remind ourselves right this formula actually the Biosawat ผมขออนุญาตเอาหูออกนะครับคุณมีปัญหาอะไรขัดข้องปัจจุบันทันด่วนพิมพ์ทางไลน์หรือพิมพ์ทางแชทในแชทใน YouTube หรือทางใดก็ตามโอเคไหมครับผมมันงงนะครับโอเคไหมเอาหูฟังเสียบแล้วมันฟังเสียงตัวเองอย่างเงี้ยมันไม่มีสมาธิในการพูดเนื้อหาวิชาการครับขออนุญาตเอาออกนะครับจะไม่ได้ยินผลตอบจากคุณทันทีโอเคOkay, are we alive at the second problem in Biosawat law? Okay, which is officially known as the magnetic field caused by the conductor that has current flows inside. Okay, in Biosawat law is the formula will tell you how strong is the magnetic field. Okay, which depends on. Let me check the voice in. Biosawat law you can determine okay how strong is the magnetic field or the magnetic flux density in terms of Tesla or volt second per meter in terms of mu zero which is the constant in current right it depends on the current and it's inversely proportional to the distance how far you observe it okay and the direction could be found from the right hand rule right with this figure Okay, that's the story we have to remind ourselves. Okay, make us refresh. And this one is zoom. What? วาลินคืออะไรเอ่ยครับวาลินผมต้องใส่หูฟังใช่ไหมวาลินครับเพิ่งใส่หูฟังตะกี้วาลินพูดอะไรนะครับผมยังไม่ได้ใส่หูฟังอ๋อหลุดตอนเช็คชื่อไม่มีปัญหาโอ้ I'm sorry for that my god แล้วยังไงนี่กดผิดโอเคมันเป็นแดงๆนี่คือใครพิมพ์อะไรมาหรือเปล่าแชทกกิตภพกคืออะไรครับไม่เป็นไรget back to the class attendance for Warin right for Warin โอเคเห็นหน้าแล้วนะวารินเดี๋ยวนะครับตรงหมายเลขอะไรนะวารินนะไฟล์ที่จะแก้มันจะอยู่ใน YouTube นะครับจะอยู่ที่ช่อง YouTube เจวารินอันนี้มันไม่ได้แก้ครับอันนี้เป็นไฟล์เบื้องต้นจะเขียนว่าพรีเซนต์ทุกคนแต่ว่าที่แก้ไขถูกเช็คจะอยู่ใน YouTube นะครับYouTube อีกช่องนึงครับที่เป็น1080 YouTube ลิงก์แรกเป็นอันที่ไปจาก Zoom โอเคไหม Zoom ไป YouTube ส่วนอันที่2เป็น OBS ไปที่ YouTube มันจะ1080โอเคthe one on YouTube Warin which is number 22คุณหมายเลข22ใช่ไหมครับวารินครับโอเควารินผมไม่รู้ทำให้คุณดูใน Zoom ยังไงนะแต่ว่ามันอยู่ใน YouTube เส้นpercent โอเคนะที่ใน YouTube นะแก้ให้คุณจะเห็นว่าผมทำอะไรอยู่เพราะว่าขออนุญาตลาครับชื่อโอมนี่คือใครเนี่ย What happens with โอมลาไปสอบเตรียมทหารไม่มีปัญหาครับลาไปสอบเตรียมทหารโอมชื่อจริงว่าอะไรทีรุธปะทีรุธหอมชื่นไปสอบเตรียมทหารครับทีรุธอาจารย์พิจารณาให้นักเรียนสอบตามความเหมาะสมชอช้างโชคสนันโอเคทีรุธถ่ายรูปมาวันสอบที่สนามสอบให้ผมเห็นหน่อยนะครับหรือคุณถ่ายใบตารางสอบคุณอะว่าตรงกับวันเนี้ยวัน21 Wednesday เนี่ยโอเคไหมคุณถ่ายหรือเอาส่งรูปนั้นมาให้ผมหน่อยได้ไหมครับเดี๋ยวนะผมพิมพ์บอกชิลุดแป๊บนึงนะเดี๋ยวลืมครับกำหนดการโอเคlet's get to our duty which is the story about Bill Salvador Reyes ไม่มีปัญหาเลยนะครับผมคุณเสียเวลา5 วินาทีถ่ายรูปมาให้ผมนิดนึงใบสอบหรือว่าตัวคุณอยู่ในห้องสอบคุณพ่อคุณแม่อยู่ในนั้นหรืออะไรก็ได้โอเคไหมครับเข้าใจอยู่ครับว่ามีใบลาจาก EP แต่ว่าเพื่อให้มันสอดคล้องกันจริงๆนะครับจะได้ยืนทันไม่มีอย่างอื่นแน่นอนโอเคไหมครับlet's get back to our story which is something about the good note, right? Which is something about the Biot-Savart formula. Okay, and the question in this one is the following. Okay, before that, they just asked us about the distance, right? How far we should stay in order to get the same strength as a ขออนุญาตถอดหูฟังครับ in order to get the same magnetic field strength or magnetic flux density as the Earth's magnetic field, right? But this one, assume that we are considering the conductor that has the current flows inside. Okay, in they asked about how much the current should be so that we can get the magnetic field strength which is caused by this conductor. Okay, the current movement inside this conductor with the same amount of the 2 times, okay, or twice the strength of the magnetic field caused by the Earth. Okay, assume that we are 5 centimeter apart from that conductor or from that wire. Okay, that's the question. Okay, you need to find the variable I, right? Well, let's get back to the Biot-Savart formula. Okay, it's not expressed explicitly in terms of the current, right? Rather, it's expressed in terms of the magnetic flux density. The value will be on the left hand side, right, in equation number 25. But what they would like to know in that example is the amount of the current. Okay, how much charge moves per time, right? Which is the current in ampere here. Okay, the variable is the variable I is our target. Okay, so you want to find the amount of I, right? You have to arrange this expression, okay, that has only variable I, okay, either on the left hand side or on the right hand side, right? So our main target is the variable I, so we have to move everything, okay, except for I on the right hand side in equation number 25 to the left hand side of this equality. Okay, first thing is that you have the denominator 2 pi r, right, here, and you have to move these 3 things. Okay, เขาตัดผมอย่างนี้เขาอยากเป็นอาหารอยู่แล้ว okay, fine. Yeah, you have 3 variables at the denominator on the right hand side, and you have to move it to the left hand side, right? So 2 pi r is gonna be appear here on the left hand side, but not at the denominator position, right? It's going to be numerator position, and mu0, which is a constant, right? It's a constant 4 pi times 10 to the power of -7, right? You have to move it also to the left hand side, right? Because our target is only variable I, and because mu0 appears here as the numerator, it's gonna be denominator on the left hand side, right? And that's the reason why you would get the final expression for the current or the variable I like this, okay, in this one. But there are a few things that we have to pay attention to. The first thing is that what value of the magnetic field, okay, for the variable B in this one. Of course, they have said here that decided, okay, the amount of magnetic field they would like to receive is 2 times, okay, is twice the strength of the Earth's magnetic field. So if the problem didn't provide the value of the Earth's magnetic field to you, you have to use any value that you can remember, okay. Well, before that, we have few problems about Earth's magnetic field, right? And then if you can remember, okay, in some books they would say 5.5 55 microtesla, or some of them may say 50 microtesla, but you can use any value, okay, as you can remember, okay, but because it depends on the location on Earth when you observe the Earth magnetic flux density or magnetic field, right? Because in this example they didn't provide that value, so we are going to use the typical amount of Earth magnetic field, which is 50 microtesla, right? Okay. In order to substitute the value of B, okay, they say twice, so we will leave here the portion B, right, as 2 times B Earth, okay. This is the variable of the Earth magnetic field, magnetic flux density on Earth, right? And then it's 55 microtesla, right? You have to arrange it into the typical SI scale, okay, typical SI unit, okay. 50 microtesla is equivalent to 5.0 times 10 raised to the negative 5 Tesla, right? That's the plain unit, okay, the unit without any prefix in front of the variable, the unit Tesla, the Tesla unit, right? And let's move to the next variable, which is the distance, the portion you are apart from the center of that conductor, right? Which is variable r, okay. And what they have provided is this one, the value, right? At distance of 5.0 centimeter. Okay, no problem. We leave 5 centimeter to the value of r, right, at this position, okay, where the variable are located in the numerator. So 2 pi is gonna be only the plain amounts, right? Plain values. Mu 0 is what you need to remember, okay. You should do several problems and you will have you will be able to remember this value, okay. Mu 0 is 4 pi times 10 raised to the negative 7, okay. That's the typical constant you need to know. And the unit of the mu 0 is Tesla time meter per ampere, right? Please know that the units will be is gonna be used later in few topics, okay, after this, okay. Awesome. Of course, here the 5 centimeter, right, in mu 0, okay. And because we want to get the amount of current in typical unit, right, which is ampere in the SI system, you have to arrange every quantity here also in SI scale, right? Please note that centimeter is not in SI scale, okay. It's not in SI units in physics, okay. Okay, if you are talking about something in chemistry, I will not object that, okay. I will not have any opposition to that. But in physics, we have to leave everything in the SI scale, okay. Centimeter is not centimeter doesn't belong to the SI unit, so you have to change it to the SI scale version of centimeter, which is meter here, okay. And 5 become 5 times 10 raised to negative 2 right now, okay. And when you observe that every unit here is of SI scale, okay, so you will now be able to leave every numbers, okay, into the calculator, or even you can use your hand, okay. It's no problem. ถ้าจริงๆมาไปก็ควรจะใช้มือนะแต่ว่าถ้ามันยุ่งยากมากเกินไปโดยเฉพาะวิชาฟิสิกส์ครับจับใส่เครื่องคิดเลขครับเพราะว่าทำงานจริงนะใครอยากเรียนวิศวะนะครับชีวิตจริงไม่ใช้หัวสมองคิดนะเพราะว่ามันเลขมันอุตลุดเยอะมากครับใช้คอมพิวเตอร์คิดหรือเครื่องคิดเลขคิดโอเคไหมครับเพราะว่าโตขึ้นสมองคุณก็ล้าแน่นอนแต่สมองตอนม.ปลายน่าจะยังสดชื่นครับโดย จนถึงปี1โอเคไหมอยากจะต้องใช้คิดมือแต่ว่ามปลายคิดมือแต่ว่าตรงนี้ฟิสิกส์ก็จะวุ่นนะพวกยกกำลังเนี่ยคุณจับใส่เครื่องเลขเลยนะครับสำหรับผมนะผมไม่มาครับyou leave everything into the calculator so the final result is gonna be the amount in the SI scale right? Is in ampere right and the answer is 25 ampere okay so in order to get the magnetic field twice the Earth's magnetic field you have to let the current flow with 25 ampere okay at the position 5 centimeter from the center of the wire okay now we complete the topic of magnetic field caused by current carrying conductor or simply speaking it's the story about Biot-Savart law okay B is mu 0 I divided by 2 pi r right it's not difficult the formula from Biot-Savart law จะเห็นว่าข้อสอบนะครับคุณต้องจำสูตรได้นะโอเคไหม B เท่ากับมิว0 I หารด้วย2 pi r งานนิดเดียวไม่ยากโอเคไหมทำจบบ่อยๆนะครับแล้วก็คุณจะจำสูตรได้เองครับไม่ใช่ทำ2ข้อแบบผมนะผมมันเวลาไม่พอนะครับมันก็ให้ดูแค่นิดหน่อยได้โอเค let's move to the next topic which is fundamentally based on the previous knowledge you have seen in the magnetic force on a chart right it's the story about F equal QB sine theta right if you can still remember that story well it's based on that topic okay the scenario is very similar it's quite similar to the one we have seen before okay here we have several symbols cross symbol right cross signs here okay what does this mean what is the meaning of cross signs here any of you can say can give me the answer what is that it's represents okay this symbol represents the tail okay the tail or the rear part of the vector right if you see the dots okay small dots okay small circle that one represents the head okay the front view of any vector right and we are talking about the magnetic field right now so the X or cross symbol here represent the tail of the magnetic field vector okay that's a magnetic field vector so when they draw the side like this it means they just tell me that they just tell us that the magnetic field is pointing into the plate oh sorry for that I have to move as well in the zoom right here it means that the vector is pointing into the plane in everything okay this one piece of cross side represent one magnetic field line okay and in this area there are several magnetic field lines right this one in I have to use the mouse that's right okay okay there are many magnetic field lines in this one right and what else as we have seen earlier the main thing is the charge right the particle okay let's say this particle contains the charge okay it has charge in sorry but it's artificial okay it's not true at all okay when they say the positive charge is it doesn't mean that this happens in nature in reality okay you will see that you will see the reason why I say it's not real it's actually artificial because inside any atom right at the heart of the atom you have proton and neutron, right? And those formulate the nucleus of any atom, right? And they don't move at all, both proton and neutron, okay? The nucleus of any atom don't move, doesn't move, okay? But the electrons, okay, the tiny particles around the nucleus are the particles that move, okay? When they say the current, okay, they gave us the current direction like this. It means actually that the tiny particle, the electron, move in the opposite direction, okay? But for simplicity, we can consider that in the artificial way, okay, in the pseudo way. The positive charge moves in this direction, moves upward like this, okay? In okay, don't pay attention to the tiny scale like that. Just imagine that the positive charge move, okay? And it has the velocity vector pointing upward like this, okay? It tries to move to the north direction, okay? SMS direction of the eye. And of course, you have the direction of the magnetic field, okay, which is pointing into this plane, right? The B field, the B vector. And of course, from the previous topic, you have faced it with the formula vector F is equal to Q, okay? Q is a scalar, and open parenthesis vector V cross vector B, right? Okay, vector B here. This one, vector B. Right. And that's the case for us. And now it's time for you to find the direction, right? You just start from vector V. Where is that vector V? Don't know. Oh, vector V. Here. Vector V. And you rotate your four fingers or your curl, okay? You turn your four fingers to the direction of the magnetic field, which is pointing into this plane, okay? ถ้าใครอยู่ที่ YouTube นะครับผมทำมือให้ดูนะครับ the four fingers that represents a direction of V first, and then you turn it to the direction of the magnetic field, right? And you have the thumb, right? ทุกคนมี5 นิ้วนะครับ you still have the thumb, and the thumb direction, okay, will give you the direction of the outcome, which is the force, okay, the induced force. So the thumb direction will represent the induced force direction, okay? You get the vector F, okay? You get the vector F here, the red vector, after you turning or rotating your four finger, okay? And that's the first feature in physics, right? The direction. For the second feature, you need to be able to compute the amount of force, right? And from F is Q V cross B, that's the vector version, okay? That's going to give you direction only. You have to use the magnitude version of that equation, which is F without arrow, okay? F is only a scalar. F is Q will be sine theta, right? When theta is the angle between vector V and vector B, right? And in this case, you can see that the angle between vector V and vector B is 90 degree, right? มันตั้งขึ้นใช่ไหมครับ มันตั้งขึ้นแล้วก็อีกเวกนึงมันจิ้มเข้าไปในกระดานนะครับ มุมระหว่าง2เวกเตอร์มันก็ต้องเป็น90ใช่ไหมครับ so theta in this scenario is 90 degree, okay? And what I have said is going to happen here also in this figure, okay? This figure is taken from another book, but it just represents the same phenomenon, okay? You have a positive charge. Oh, I'm sorry to mention about the cross-sectional area, okay? The different things that we have in this figure from the previous scenario is that the chart that doesn't move freely. Oh. Okay, the chart doesn't move freely. Okay, it's move inside the copper wire. Okay, the conductor here. Okay, it has some limitation of movement. Okay, it doesn't move freely. Okay, the pipe or the conductor is the media that allows the chart moves in this scenario. Okay, and actually the conductor is long. Okay, is straight. Okay, we don't talk about the bending shape of the conductor เราไม่พูดถึงเรื่องเส้นลวดตัวน้ำที่มันโค้งๆนะเราเอาเฉพาะเส้นตรงครับโอเคไหมthe conductor is just straight up and it's a line. Okay, it's linear, it's straight, it's long, very long. Okay, and we will take a look at only a certain length of that long straight copper wire. Okay, we just take a look or pay attention to a portion of that which is of the length L. Okay, it's denoted by a variable L, and of course it's the true, okay, the realistic conductor. It's not the lie, okay, which has no size at all. Usually, even it's small, we can still have the cross-sectional area. Okay, if you cut it by a very sharp tool, okay, you get the cross-sectional area of that conductor, and let's say it is represented by variable A. Okay, it's the cross-sectional area. Okay, and that's the scenario in this topic. Here you can have also another setup for the same phenomenon. Okay, that's in the previous figure. You have the chart movement along the conductor, which is arranged right up, right? But this one is represented in the horizontal way. Okay, it's in the horizontal way. The chart moves right now horizontally. Okay, before that the chart moved vertically, and it's just moved from the left hand side to the right hand side. Okay, in this figure you can see that they didn't cut the conductor at all. Okay, the conductor is straight. Okay, it's long, it's linear, it's straight, it's long enough, but they take a look. Okay, they take a look and pay attention to only a certain length of that long straight copper wire. Okay, which is of the length L. Okay, and they assume as well the magnetic field is pointing, okay, with the green dot, no, sorry, the green X symbols here. They just say the magnetic field is pointing into also the plane of this lecture note, this paper. Okay, you can also get the scenario that the vector is pointing to us. Okay, is pointing out of the plane of this lecture note. Okay, but this is only one case for that. Okay, the magnetic field is pointing into the plane of the lecture notes. Okay, and you find that you start from the first vector, right, which is vector VD. Okay, vector VD. Okay, you may ask me what is the reason why they have the subscript D. Okay, under the variable V. Okay, the meaning of the is that they just want to mention that this is the drift velocity. Okay, it's drift velocity. What does that mean, drift velocity? It means only the chart, okay, only the chart moves. Okay, not the conductor move. Okay, the conductor doesn't move at all in this configuration. Okay, you can see that the conductor doesn't move. Okay, have you ever seen the conductor moving along the road? No, the conductor or the copper wire just stay constant along the road, right? คุณไม่เคยเห็นสายส่งกระแสไฟฟ้ามันวิ่งใช่ไหมครับมีแต่สายส่งกระแสมันอยู่นิ่งๆโอเคไหม so the subscript D just represent the drift feature of the chart, okay, inside the connector, okay. And you just start from V again, okay, because vector F is V cross B, right? So V is pointing from left to right and B is pointing into this plane, right? And you use สำหรับคนที่อยู่ YouTube นะครับ you curl or you rotate your four fingers, right? You will get the outcome, the output as the direction of your thumb, okay? And in this scenario you will find that หมุนแบบธรรมชาตินะโอเคไหมคุณไม่ต้องดัดนิ้วเหมือนคนลำไทยนะโอเคไหมคุณหมุนมือธรรมชาตินะครับ V ไป B นะครับ you will find that your outcome, the thumb direction is going to point upward, okay, straight up like this, okay. The outcome, the vector F is in blue line here, is pointing upward, okay. And that's the same thing. It doesn't matter whether the connector lies horizontally or vertically, okay. And for the sake of magnitude, okay, as I told you, you can use the magnitude version of FQVB, okay, which is absolute QVB sine theta, and in this scenario, theta is 90 degrees, okay. In F is the magnitude of the vector F, okay. In Q is the chart of that moving particle, okay, and VD is the drift speed or drift velocity, and B is the magnetic field or magnetic flux density, right? In Tesla, angle is 90 degrees, okay. Especially for this situation, okay, when the angle between V and B is right angle, which is 90 degrees. Okay, now we move to another scenario, which will cover all of what happened in that current movement in the long straight Y. Assume that there's not only a single chart or particle moving in that area, okay, but rather we have n moving particles, okay, n moving particles inside that one in okay, capital N, okay, and then the connector we are interested in is of length L, okay, and let's say the small n, okay, is a variable, okay. It can change its value, okay, from 1 to until the last index, okay. If you have 10 people, so the first person is denoted by number 1, right? The second person is denoted by number 2. It's something like that, okay. And we have n charges, okay. It's a moving particle, and we can apply the FQVB to each particle, right? And you will get F as the absolute Qn, okay, times Vd, which is the drift velocity for the particle. Assume that all particles move with the same speed, okay, with the same drift velocity Vd, and assume that in that area the magnetic field doesn't change with time, okay. It's the value of magnetic field just stay constant, okay, and that's the typical thing that can happen. Qn is the chart for the n moving particle, okay, and if we have all n particles move at the same speed, okay, Vd, we could determine the velocity from the usual expression, right? You know that Vd is distance per time, right? So distance here is the distance here. If you take a look at figure whether 33 or 32, okay, the portion of interest lasts only L, okay, only L. And here whether the vertical version, okay, of length L or in the horizontal way, it's also of length L, Okay, it has the length of L like this. Okay, and that's the distance, right? And we assume that the distance is L, and we assume that the observation time is delta t. What does that mean? It means if you take a look at this figure, okay, it's like the situation if you watch the Olympic match of running, okay, the referee will take the sound beat, okay, as the starting time, right? Okay, you capture the time, and the runner are going to walk, are going to run from left to right like this with high speed, okay, and when they arrive at the final line, okay, which is the final, at the ending point here, okay, you will the referee just stop the clock, okay, and the time that you use from the starting point to the ending point is going to be set as delta t, okay, in this variable, in this equation, sorry, in the variable delta t in equation number 30, okay, that's the measurement time, okay, for the runner or for the shot that moves inside the connector, okay. We now arrive at this figure, okay. In this figure will tell you what is going on in nature if you leave the current flowing inside the connector, and in that area there is also magnetic field, okay. Okay, let's take a look at the first case on the left hand side, okay. The first case is that there is no current moving at all, okay. There is no charge moving at all inside the connector, okay. And even in some areas you have mouseติดสายครับ in some areas you have magnetic field really strong, okay, and but nothing is going to happen, okay, because there is no charge movement at all inside the connector, okay. That's the first situation. There is no charge movement in this area at all. So let's take a look at the second scenario, and here you will see that the shape of the connector is now bending to the left, okay. Before that it just stay upright here, but straight like here, but when there is current, when there is charge movement inside this connector, the shape of the connector now becomes bent, okay, to the left like this. Oh, what happens? Oh, okay, this can be explained by the following. If you apply the right hand rule, okay, of course the v vector is going to be upward like this, right? The v vector is going to point upwards. That's the first vector, and you cross it, you turn it to the direction of b, okay. In this scenario they use the cross sign, the cross symbol, which represent the direction of magnetic field pointing into the plane of this lecture note of this paper, right? So v to b, after v to b, right, after you use your right hand, you will find that your time direction is going to point to the left, okay. So the magnetic force is directed to the left hand side, so that's why every force in this area will bring the connector to the left, and that's why you get the left bending shape of this conductor. Now let's take a look at the last figure, the third figure here. You have again at the beginning you have the straight light connector, okay. The connector is just positioned right away here, okay, in the linear way, and after that you let the current or the charge move from the upper part to the lower part like this, okay, from the top to the bottom, okay, from the top to the bottom like this. You will see that the velocity vector is going to point downward, okay. It's going to point downward like this, and you start from v, right? V again, v to b, okay. B is the right the vector of magnetic field which is pointing into the plane or the paper. So V2B, after you use your right hand, you will find that your thumb direction is going to bring the conductor to the right hand side in this figure. Okay, so that's why the shape of this straight conductor is right away here. Okay, and here is what's going on. But okay, this is what you could observe in nature, but we are studying physics, okay, which is a subject of science. We have to go into the detail. How much, okay, how much does the force will take place in these two scenarios, in these two situations? So let's move to the next page, which will give you the detail of the amounts of force that we can get from the last two figures in the previous page. Okay, let's say we introduce a new variable, which is the capital Q. Okay, the capital Q is the total amount of charge that includes every moving particle. Okay, each moving particle has its own charge, but in that area, let's say we have the total amount of charge by variable Q, okay, which is the summation of each charge. Okay, we don't care whether it is positive or negative. Okay, just make the summation. Okay, and after that, an electric current. Okay, an electric current is from ampere, from ampere, right? Ampere said the current is the amount of charge moving, charge movements per time. Okay, so the total charge movement is variable Q, right? And the observation time from the starting point, from P by the referee and at the final line, okay, it's large delta T, right? It's the variable delta T. So that's why delta T appears here at the denominator position. Okay, that's a typical ratio from the current formula, right? Now let's move to the next figure, next page, which gives you the idea of the whole amount of the force that happens in the last two figures while the conductor are bent. Okay, so in this one, you just use the FQEB for each particle, okay, in equation number 29. Okay, and the force, the total force is the summation of all forces that happen to each particle, right? The total force is the summation of all n particles, okay, all n forces, okay, because there will be force number 1 for the first particle, there will be force number 2 for the second particle, for the moving particle, right? Moving charge. Because we assume at the beginning that we have capital N particle or capital N charges, right? So the total force is going to be the summation of all of these amounts. Okay, and let's get into the force for the N particle. Okay, the small N particle, it's actually absolute Q VdB, right? So we will substitute absolute Q, okay, from this one to the position of Fn, right? So you have absolute Q N Vd and B, right? Vd is drift speed, right? Drift velocity. And now let's get into the detail of each variable. Okay, the first variable is absolute Qn. Of course, this is the expression of summation, right? But the last two variables, such as Vd and B, don't depend on small n at all. You can see that Vd doesn't depend on n. B doesn't depend on n because B is uniform for every particle, because VD is constant for every particle. Every particle moves with the same speed, so they have the same value of drift speed. But each particle has different value of charge. So only the first term, okay, summation of Qn will depends on n. So we assume that the summation of Qn here is equal to Q, right? That's from the equation number 31. Okay, 31 says that summation of absolute value of the Qn is the capital Q. Okay, the total amount of charge in that area. Okay, in the area we are considering that's current. Okay, so summation of Qn is equal to capital Q, right? And let's take a look at the drift velocity. Okay, drift velocity, as we have seen before, is equal to distance L, right? Distance L divided by delta T, right? It's the normal way you have seen in Matrium 5 and Matrium 4, right? It's by T, right? And the last, the last variable, which is magnetic field, okay, we have nothing to do at all with variable B, okay, just leave that, okay, just leave the variable B, okay, like that, because we cannot do anything with B. Okay, now we arrive at the next equality, almost the final line. Okay, you have Q, okay, now you change Q. Of course, we know that I is Q divided by delta T, right? I is Q by T. You know from 32, this one, right? I is Q by delta T. Here. Oh, sorry. I is Q by delta T, right here, right? But what we would like to know is the variable Q, right? So we move delta T to I. We move delta T to I to the left hand side. We get Q equal I times delta T, right? And yes, we will replace Q. We will replace Q by I delta T into this expression, into this position, okay? And we leave it I delta T at the line before the final one. Okay, you have I delta T, but in the second term, you have also delta T at the denominator position, at the lower position, right? Delta T will cancel each other in this equality, right? So finally, you get only ILB. Okay, that's the final expression, the magnitude expression of the induced force when the current moves through the long straight copper wire. Okay, what we can refer from this expression is that it doesn't depend on the cross-sectional area at all. Okay, it doesn't depend on the cross-sectional area of that conductor at all. It doesn't depend on the total amount of charge at all. Okay, it doesn't depend on the delta T. Okay, when the referee let the side beat and then the measure at the end of the running competition. Okay, there is no relation to delta T at all. It just depends on I and L and B. Okay. So now we move to the next page. What happens if the angle between vector B and vector V not 90 degrees? Okay, when the angle is not 90 degrees, it's not the right angle, what could we do? Okay, you know that before we have the right angle, right, between the vector, the direction of the current movement and the magnetic field direction, right? The B variable, right? So what could we do then? Okay, you just derive it. Okay, you just start from the same way you make the analysis for the right angle situation. Okay, we change the variable theta to phi. Do you know the reason why we don't use theta at all anymore? We use the angle phi, because I take the content from different book. Okay, in some books they use the angle, the Greek letter theta. In some books they use the Greek letter phi. Okay, but it just represents the angle between vector v and vector b. Okay, or vector l, vector b. Okay, in this topic. Now we will talk about how we determine the direction of the induced force when the angle between the conductor and the magnetic field is not completely right angle. It's not exactly right angle. Let's say it's angle phi. Okay, it's angle phi, right? And of course, ILB comes actually from vector F equals I open parenthesis vector L cross vector B. Okay, it's similar to the vector version formula you have seen before, right? Vector F is constant Q open parenthesis V. Okay, the velocity direction vector cross B. Okay, the magnetic field vector. Okay, but in this case it's not free charge movement, it's charge moving through a long straight conductor, right? So we are going to say this is the vector L. Okay, L is not vector, but L is only the length of the portion of conductor that we are considering. Okay, we are paying attention to. Okay, but we will say this is the vector L simply because L is the magnitude, but I, okay, is direction of current movement. Okay, that represents the direction. So we will say this is the vector L. And of course, vector B is right there. Okay, this is vector L. Here is vector B. And now you have the angle, which is not exactly right angle. It's only something less than 90 degrees. Okay, and the way to determine the outcome, which is the induced force, the red vector here, is to use again your right hand. ทุกคนห้ามมือขวาหายโอเคไหมครับห้ามทำมือขวาหายเรียนจบวิชานี้ก่อนค่อยทำมือขวาหายนะคุณอย่าไปดื้อซุกซนนะครับโอเคไหมเก็บมือขวาไว้ตลอดชีวิตโอเคไหมครับเพราะมันใช้อยู่นะครับyou just use the right hand, okay, in order to find the output or the outcome vector F, the red vector. Okay, you start from the vector L, you turn or you rotate your 4 fingers from the first vector L to vector B, and you will find again that the output vector is going to be the thumb direction. Okay, as they have seen here. Okay, you curl your 4 fingers, you rotate or you turn your 4 fingers from the first vector, from vector L to vector B. Okay, according to the arrow here, the arrow of turning direction here. Okay, you will get the thumb direction. Okay, which is the rotation axis here. Okay, you get the direction of the induced force in this way. Okay, now let's move to the qualitative analysis. Okay, the analysis of the amount. Okay, of course you will see that what we have seen before is the result when the angle is 90 degrees, right? When the angle is 90 degrees, but this one is not 90 degrees. Okay, vector B can be projected or decomposed into 2 components, right? The first one, of course, this is the angle phi, right? If you project it onto the same axis as the conductor, there will be nothing happen because L and B, V and B are in the same way, it's in the same direction, so there is nothing happen. But the component that matters to us, okay, that is significant, that is important to us, is the this component, okay, which is be with the subscript parallel, okay, the parallel symbol here. And of course, when you decompose this vector into that one, you have to use B side phi, right? Okay, because this component is parallel to this line, and this line is in the opposite way to this angle, so you have to use function psi, right? Okay, you have to use function psi. So now it means that the component that matters, okay, that is significant to us is B with perpendicular subscript. Okay, so we are gonna use B psi, which is B with subscript perpendicular, to the formal, to the typical expression here. Okay, to the typical expression that we have got before. This one in YouTube เมาส์มันเร็วนะครับไปอย่างเร็ว okay, the one you get from 33, okay, is ILB, right? But B in this case is the case when B is made with right angle to the vector L, right? So we will substitute B psi phi into this expression, and that's the key. Okay, that's the only one part that changes in this scenario when angle phi or theta is not right angle. Okay, we substitute B with perpendicular subscript into the typical result in equation 33, right? So finally we get ILB psi phi, okay, as the new result. Okay, you can apply 34 to any situation, okay, whether it's right angle, it's 90 degree or not, it does matter. Okay, you can apply 34 for a large number of problems right now. So now let's talk about the vector version, which is 35. Okay, 35 is the vector version of 34. Okay, it's similar way as you have seen earlier นะครับพวก vector version นี่ผมเอามาใส่ให้คุณในระดับชั้นม.ปลายนะผมไม่รู้ว่าคุณเรียนพิเศษเขาใส่เวอร์ชันที่เป็นเวกเตอร์ให้คุณไหมเพราะว่า cross vector มันอยู่ในระดับชั้นปริญญาตรีนะคนไหนเรียนพิเศษเขาสอนอะไรนะเขาสอนถ้าคุณพูดผมจะไม่ได้ยินนะเพราะผมไม่ได้ใส่หูฟังนะพี่มาเดี๋ยวใส่หูฟังกันนะที่ไหนเขาสอนเวอร์ชันที่เป็น cross vector ไหมเอ่ยนี่ไหมครับนี่ไหมใครไปเรียนพิเศษมาแล้วโอ้ยผมก็เรียนนะตอนสมัยผมเรียนมาไปผมก็เรียนพิเศษนะโอเคไหมมีไหมครับคนอยู่ซูมมีไหมเอ่ยไม่มีคนอยู่ซูมกันละหรือว่าอย่างไรครับเขาตอบนะครับไอ้พวกเวกเตอร์ f เท่ากับ qv cross b เนี่ยมันคือระดับชั้นปริญญาตรีนะผมไม่ได้บอกคุณไอ้เช็คเช่นเดียวกันไอ้สมการ35นี่ก็เป็นอยู่ในระดับชั้นปริญญาตรีผมเอามาใส่ให้คุณเพื่อคุณจะได้เข้าใจชัดเจนเลยว่ามันมาได้ไง ILB psi phi มันคือเวกเตอร์ cross กันนั่นเองใช่ไหมเงียบไปเลยทุกคนยังอยู่ไหมครับ Are you still there 605นี่นำ604ละอาจารย์ครับแบบนี้ได้ไหมครับอันนี้มันกัดสิดิตเนี่ยใช่ป่ะห้อง604ทำกันบ้านเดี๋ยวค่อยตอบเขาไม่เอามันนี่เวลา605เดี๋ยวตอบให้งงเรื่องกันบ้านอะไรถามได้นะครับถามว่า35นี่คุณได้เจอมาก่อนไหมHave you ever seen this version? This is the complete version. In bachelor degree, it's IL cross B. Okay, and if you know the characteristic of the cross product, you find that it's the magnitude of those two vectors, and then there will be a factor psi of an angle. Okay, and that angle is the angle between two vectors. Right? Okay. Okay, phi is the angle between phi is the angle between vector L, okay, and vector B. You find, you may ask me, where is vector L? There is no vector L though. Vector L is only a pseudo vector, okay? It's the vector that represent that has the direction of I, okay, and the length of vector L is the L without vector here, okay. That's the scalar version, okay. So vector L is pointing in the same direction as the current, and its magnitude is simply variable L, okay. And now let's take a look at this figure. We would be able to compute the direction of the force, okay, induced in this case, okay. As I told you, you start from vector L to vector B, okay. You can see that vector L is right here, okay, and you turn or rotate your 4 fingers from L to B, right? And from the right hand rule, you get the vector F, right, in the same direction as your thumb finger, okay, your thumb here, and that's why you get the induced force upward like this, okay, upright from the plane, okay. And now we ทุกคนพอได้ครับเดี๋ยวผมลองใส่หูฟังดิมีคนติดขัดอะไรไหมครับyou had อยู่ไม่เอาดีกว่าไม่ฟังหูฟังครับมันทำให้เสียสมาธิครับ okay. You have the result or the outcome from this situation, right? Now in order to better understand, right, we will have some problem to practice, okay. When the angle phi is greater than 90 degrees, what happens, okay, like this, okay. In this scenario, you have angle phi greater than 90 degrees. What happens? You have to rotate, or you curve, okay, rotate your 4 fingers from the first vector, which is vector L, to another vectors in the way that you have the angle less than 180 degrees, okay. You are not allowed to rotate your 4 finger in this way, okay, in this way to vector B, okay, because in this way you have the angle greater than 180, okay. We won't do that. We will do the rotation only in the way that we have angle of rotation less than 180 degrees, okay. You understand? And after you do this, okay, you start from vector L to vector B, you will find that the outcome or the induced force is pointing downward like this, okay. And that's the case for this one, okay. If you practice, you will better understand what is going on in this topic, in this theory. Now let's move to another situation when you have L like this, okay. It's pointing in the negative x and in the negative z, okay. The vector L is pointing in this way, okay, and that's the first way, the first vector you have to realize, okay. You have to keep in mind. And in the second vector you have vector B, right, which is pointing to the left hand side, which is pointing along the negative x-axis. But this is the second vector. We have to start from the first vector, okay. What is the first and the second vector? Yeah, yeah, the first vector is the vector L, okay. You have to rotate your 4 fingers to you have to turn your 4 fingers from the first vector to the second vector, which is vector B, okay. And that's what I always mention. In this case, in figure 39, right, 39, you start from vector L to vector B, right. You use your right hand, right, your 4 finger start from vector L to the vector B, right, to vector B. You will get the thumb direction, which is which indicates the output direction, okay, the induced magnetic force, which is upright here along the positive y-axis, okay. And that's the lecture for today, okay. the time is so นะหรือว่าคุณจะให้ผมต่อคุณนำ604ไปเยอะเลยโอเคไหมครับso it's time now we have to leave the lecture okay we have to quit the lecture if you have any question just let me know โอเคคุณไม่เข้าใจตรงไหนนะครับถามได้โอเคไหมครับif not then we are going to leave the lecture and please prepare yourself for the upcoming Friday. Okay, we are going to have midterm exam. Please check your camera. If you don't have camera available, you will get deduction of the total points in the midterm exam. Okay, that's our agreement. So we have to leave the lecture right now. See you on Friday. Good luck, everybody. Bye bye ครับ สวัสดีครับ Oh, I have to zoom right. Stop and end the stream.